Hey guys, so I want to show you a simple playbook that I built that's supposed to run a file reputation action via virus total against all hashes found in the container. But first I want to talk about a good playbook design and in other words, why I created such a small and short playbook. So there is a reason for that. I want to take you to this page. Okay, Splunk Lantern, following best practices for designing playbooks. They have some very good tips. So good playbook design uses smaller, more focused playbooks that interact to perform complex tasks. If your playbook don't work as expected, consider breaking up single complex playbooks into modular ones that call each other. These are easier to maintain, debug, develop, etc. Actually, just like code design, want to make it easier for us to maintain in the future. And there is an even more important reason why I want to consider doing that, because by creating modular short playbooks to perform complex tasks, it helps you in the future if you want to create some more complex tasks. In many cases, you can use the same modular playbooks that you already have and created in the system, instead of just duplicating and creating again the same blocks and actions. So this is also why you want to consider short and simple playbooks. So a playbook, in my opinion, should serve one main purpose. And for example, if we want to continue this playbook to a second playbook, if we have some knowledge about the user who inserted the malicious hash to the system, such as username, IP address, etc., we can use the end block to create some output variables and pass this information to the next playbook, to continue the investigation and respond accordingly. Now, for the sake of the demonstration, I created a container with 3 artifacts in it. Each artifact contains different types of hash. We can see file hash, SHA-256. We can see SHA-1. And here I duplicate the same hash from here. And also I created a fake hash just to show you how it works, okay? So one thing we should know before we start, that when we use the picker to choose an input, a data path to insert as input, we can choose only one data path, right? We cannot choose multiple data paths. So what if we wanna choose a few data paths to make sure we catch all the all the types of hashes, right? What can we do to overcome this issue? So one thing we should do is to duplicate the action block as many times as we want, one action for each data path. But then we will need also to duplicate the continued blocks, right? However, there is a workaround for it. And the workaround I found is to add all the hashes from the different data paths to one list and insert that list as one input to the action block. And then it will be able to run against all hashes from the different data paths. So now we can begin with the playbook. So the first thing we want to do when we start a playbook is to make sure that we have the fields that we want to run the actions against, right? So I call the condition if hash exists, okay? You can see here, and I entered all the different data paths, all the different types of hashes, and I wanted to make sure that at least one of them is not equal to none, right? The file hash or the SHA-MD5, the MD5 or the SHA-1 or the SHA-256. In this case, we could also use the decision block, so it doesn't really matter which block we choose. If we do have hash exist, we can continue to the next block. And here I want to take you to the list merge utility. Let's look for the description. Okay, merge different data paths into a single output data path. For example, if IP addresses are stored in the fields source address, destination address, and device address, then those three fields could be merged together to form a single list of IP addresses. Okay, so it's exactly the same issue as we have here in our case. We have a different data paths of hashes, and we want to organize all of them in one data path. So I insert all of them as inputs, and we do have one list. Now there is another utility called list duplicate, which basically remove non-unique items from a list. If you remember, I duplicate the hash in the container. So this utility removes the non-unique items to make sure we have only unique items in our list. So I inserted the list merge item here, and now we have a list clean from duplications and ready to use. There is also a utility you should know which called I think remove non-value from list, something like that, and that helps you to remove non-types and from the list if it helps you in cases. So now we can run, we can insert the list, the duplicate. You need to make sure that you need to untick this filter to find the relevant blocks that you created. After the file repetition action ran, we need to call filter block, okay, to make sure that we catch results. We need to make sure that we find a result status equals to success, and that we have at least one vendor that marked this hash as malicious, right? So I want to make sure that it's the number of malicious is greater than 0. And if so, if we find a malicious hash, we continue, we call the format block and organize the results. The hash, this input is malicious. Now you can see that I wrapped the sentence, and also I used asterisk. I'll show you it in a second, but one thing you should see is that I use filter, and from the filter I pick the hash, okay? Because that way I make sure that only the hashes that were matched this condition will move on to the next block. Only the hashes that were found malicious. So to show you why I use this wrapping and asterisk, let's see. Okay, I want to take you to this page. Customize the format of your Splunk SOAR playbook content. You can see that I use wrapping around the formatting block to make each set of values output on its own line. Okay, you can see that they use this sentence, and it creates one line for each output. Okay, so it's the exactly same thing that I do here. And as far as the asterisk, in this page, view and create notes in Splunk Phantom, you can see that Splunk Phantom uses the Markdown flavor as GitHub uses, and they refer us to this page. Okay, so now we can see that we have basic writing and formatting syntax, we have styling text, we have bold, we have italic, and so many more examples that you can see. We can organize the notes with links, section links, what else? Also lists, which are very helpful and make the note readable. So I just wanted to make this word bold to show you that we can do that. Okay. After we use the format to organize the results, we added these utilities. We promote this event to a case, and you see, because I promote it to a new case, I have to choose to which template to attach a workbook to. Okay. We add note to the container. I use this title, and for the content I use the formatted data. Okay, not format, of course, is markdown. And the severity, we set the severity to high, because we did find malicious hashes in our system. Okay. Okay, so this is the playbook. You can see that the ID of this, the ID of this container is 6, so we can run the playbook. I'll save the playbook just a second. Usually we enter readable comments, and so demo. And by the way, all the changes that we made in our playbook, we can go back to revision history, and if we regret of the last change that we made, we can go back to revision history, and just like Git works, we can restore our work. Okay. So now, after we saved the playbook, we can run it. Let's run to make sure that the scope is set to all artifacts. Let's wait for the playbook to stop, to finish. On finish code, that's great. There is no red marked sentences that notice us that there is a failure. We can see that we start with a filter block, and we have at least one condition that is true, so we can move on. Okay. We use the list merge. We can see that it did work. We have all these hashes in the list. Now we call this the duplicate. We call the file reputation. We can see that 2 actions succeeded, 2 actions failed. Okay. Now let's see why. The first one worked, as we can see. For this hash, we have message error from server, message not found error. Okay, it gave us a not found error failure message. As for this fake hash, we did get a message hash failed validation. So we have 2 hashes that failed and 2 hashes that succeeded. Okay, we find 58 vendors that marked this hash as malicious. And now we can move on to filter the results. We can see that phantom condition returned 0 filtered artifacts, but it did return 2 filtered action results. Okay, because we have 2 hashes that were found malicious, 2 hashes that match our condition. No, sorry, not this filter. 2 hashes that match this condition, status success, and number of malicious. Just a second, number of malicious is greater than 0. So we can move on. That's about it. We add now to promote to case and we set the severity. Now let's see the results. We can see that it was promoted to a case, severity was set to high, and we do have a new note, malicious hash found. We have separate line for each hash, which was what we wanted to do. Of course, it was just an example of how the playbook works, and you can design your own playbooks in any way you want. You can add tasks, you can configure new playbooks to continue the investigation based on the artifacts that you found here, and basically it's up to you to develop design, and that's it. One thing you need to make sure when designing a playbook, that it will be able to work against the containers in the way they are ingested to your system. For example, you need to make sure how the artifacts are called. You need to make sure how the Ceph values are appearing inside the artifacts, just to make sure that the playbook will be able to run correctly. So that was it for this video. I hope you like it. If so, do subscribe, and I'll see you in the next videos. Bye.